Alright guys, welcome back. So we're going to get started with 6.4 graphing sine and cosine functions. So sine and cosine functions are periodic functions. They're creating a wave, going up and down, repeating and oscillating in both positive and negative directions forever. So obviously because it's repeating forever, we're never going to be able to graph the entire thing. Instead, we're going to simply graph one cycle, as they're illustrating right here. The cycle that starts at 0 and it ends once it repeats itself. Both sine and cosine. So our graphs are going to look kind of like these two pieces right here, one cycle. That's just for this class. Future classes of yours, you might end up having to graph more than one cycle. You might have to graph in between a certain period of range or whatever. In those cases, just pay attention to what your teacher is looking for. I'm just going to be looking for one cycle based on the starting at 0 location for both sine and cosine. So the general format for your graphs is these two equations right here, where each of those variables A, B, C, and D are all involved in some way with finding these different pieces of important information. A is helping us find the amplitude of the function, how high and how low it goes. B is helping us find the period of the function, how long it takes for the cycle to repeat itself. C is the horizontal phase shift, how much is going to shift left or right, based on that starting at 0 location, which is the original function. And then D is the vertical phase shift, again, how much is shifting up and down based off, again, that 0 location for the original function. You're sometimes calling that the midline value, which is very important and very useful for making the graph itself. Now, of those four things that we have to find, again, how we're getting them, it all kind of depends on the equation they give us. The amplitude is just simply the absolute value of A. Now, that's not to say if A is negative, it doesn't really do anything for us. When A is negative, that does tell us the direction of the graph, whether the direction of the graph is starting off positive or starting off negative. So it's important to recognize when A is negative, but the amplitude is the distance. Something is from the midline to either the peak or the valley, in which case that's why it's always the absolute value, because distance is always a positive number. The period, so the basic function without any sort of shifting or transformations of any kind, is 2 pi, your unit circle, how long it takes to rotate all the way around. So the b value, you're doing 2 pi divided by b to find the actual period. And we're using this omega symbol right here to identify the period, 2 pi over b. Now the horizontal phase shift, you might recognize this, and hopefully recognize this really from Unit 1 when we talked about transformations of functions. This is how much we're going to shift to the left or to the right. Now more often than not, you're going to have an equation set up kind of like this. It'll be 2 theta plus, let's say, 3 pi over 2. And if they give us something like that, that 3 pi over 2 is not the horizontal shift. You'll need to factor it away. But we need to recognize that when we factor, you're dividing the original by which you're factoring away that. So 3 pi over 2 divided by 2, so you can guess 3 pi over 4. You can always check that by distributing back into it. So that 3 pi over 4 would now represent the value of C, which is now the horizontal shift. And because it's a positive C, this is shifting to the left, whereas if that was a negative C, it'd be shifting to the right. All right, so that's the only one that will require at least a little bit of effort. Amplitude is just simply the absolute value. Period is, yeah, division, but it's 2 pi divided by a b value, which is not going to be very challenging. C, as long as you're careful with your factoring rules, not too bad either. You just have to remember to actually factor and be careful with how you're factoring it out. And then vertical phase shift is just the number that's adding or subtracting on at the end. If it's a positive, we're going up. If it's a negative, we're going down. All right, so for here, we're not graphing or anything like that yet. We're just identifying the amplitude, period, horizontal phase shift, and vertical phase shift. So our amplitude is the absolute value of A, absolute value of this 6 right here, which is positive 6. That's it. Our period, omega, is 2 pi divided by b. Our b is the number in front of theta, so 2 pi divided by 6 is pi over 3. As for the horizontal shift, well, that's going to be based on factoring this theta, the 6 away from theta, and the 5 pi over 6. And again, when we're factoring, we're dividing, so we're doing 5 pi over 6 divided by 6. And when we divide with fractions, you multiply by the reciprocal. So it's 5 pi over 6 times 1 over 6, which is 5 pi over 36. That's what will go on the inside. So that's our horizontal shift, 5 pi over 36, and we're going to the left. And then finally, our vertical shift is a negative 4 at the end, so we're going for down. We never specify the shift as a negative number. The negative is specified by the direction itself. So the vertical shift is 4, because it's -4, it's going down. The 5 pi over 36 that's inside the parentheses is a positive, that's why it's going left. Had that been a minus sign in there, then it would go right. All right, so that's our amplitude, period, horizontal shift, and vertical shift. I'll take a look at another one. So here our amplitude again is the absolute value of A. Absolute value of -4 is +4. Our period is 2 pi divided by B, and B is a half here. Because it's theta over 2, that's the same thing as 1/2 theta. So if you divide by a fraction, we multiply by the reciprocal. So it's 2 pi times 2 over 1, which is 4 pi. The horizontal shift, we're factoring the 1/2 away from theta and from the 5 pi over 3. So if we do 5 pi over 3 divided by 1/2, we're doing 5 pi over 3 times 2 over 1, which is 10 pi over 3. So that's our horizontal shift. It's 10 pi over 3. And we're going to the right because it's in minus sign. We're not writing a -10 pi over 3. We're just writing 10 pi over 3. The minus sign tells us the direction, and the direction is going to the right. And then the vertical shift is the +2 at the end. It's a positive, so we're going up, so it's 2 up. All right, so that's all we're looking for if they just want us to identify amplitude, period, horizontal phase shift, and vertical phase shift. If we want to graph these things, we're going to need to identify the amplitude and period first. And for a simple trig function, that's all we'll have. There won't be any shifting horizontally or vertically. We'll get to those after we do a couple of them without it. And then from there, in addition to that, we want to be able to find out where we put all the points. Now, the horizontal points are based on these 5 locations. 0, where we start, the quarter period, the half period, 3/4 period, and the period itself. So the idea is, the 0 is a starting point, you get your period, and you're just going to do a quarter of that, half of that, 3/4 of that to find the next 3 points, and then the 4th horizontal point will be the period itself. And then the corresponding y locations to each of those horizontals will either be one of 3 options. Because we're trying to make this thing as simple as possible, we're not going to go too crazy. It's either going to be the highest point, the peak, the lowest point, the valley, or the midline in between. The exact location will depend on what type of trig function we're dealing with, and then also whether or not what horizontal point we're going to focus on at that particular time. And the peak and valley is based off the positive and negative value of A. So if A is 3, we're going to go as high as +3 and as low as -3. If A is -5, we'll go as high as +5 and as low as -5. So we still go to highest and lowest for the positive and negative values of that A value. Whether A is positive or negative helps show the direction of the corner points. And that's what we're going to see when we're doing each of these things. So y equals 5 sine of theta over 3. So our amplitude is 5. It's the absolute value of 5, which is just simply 5. Our period is going to be 2 pi divided by 1/3, which is 2 pi times 3 over 1, which is 6 pi. So when we set up our graph, we're only going to do it based off the positive values here, because we're only looking at one thing. So we're going to mainly focus on just simply on the right-hand side of it. We will take a look at the negative side of the graphs when we start talking about horizontal shifting. But if we're just doing the basic function without a shift, it's going to be based off the horizontal side. There's going to be 4 horizontal values. And then here we have 5 vertical values because it's going as high as 5 and as low as -5. And you're going to have to create your own grid for each one of these things just to make it a little bit easier, because since everything is constantly changing, I don't want you to have to do it on the same grid where you're going to have different, period values, therefore the functions look totally different. So you're going to find that the shapes are going to look actually the same, even though all the values on the horizontal and verticals are going to be a little bit different. If you were to graph them one on top of the other, they wouldn't be totally different at that point. And be careful trusting the calculator to do anything this for you. A, it has to be in radians. All these graphs are in radians mode. And B, if you don't adjust your window, it's really not going to look the same as what we come up with anyway. Now again, for those horizontal values, you're doing the quarter period. So the quarter period would be a quarter of 6 pi, which is 3 pi over 2. You're then doing the half period, which is half of 6 pi, which is 3 pi. And then we're doing the 3/4 period, which is be 3/4 of 6 pi, which is 9 pi over 2. So those are the first 3 horizontal values. And it ends at the period itself. Now, for the actual points. So the way it works is sine will always start at 0. always start there. And then the second point will either be the positive or negative value. It's going to be whatever the value of a is. So since a is a positive 5, we're going to go up to positive 5. And then from there, the pattern is once we're at the peak, it then goes to the midline, and still following the downwards direction, so then we go down to the bottom, the valley. Once we're at that valley, then go back up to the midline, and we've hit all the 5 points we need. If you were to graph more of this, you would then go up to the peak again, then back to the valley, back to the midline, then to the valley, and just kind of keep on going like that in both positive and negative directions. Now do your best to make this look more like a curve and less like a bunch of triangles. But that's the graph we're looking for. And that's going to be the general shape for every single sine graph we do. You'll just find there'll be different peak and valley points because it's not going to always be a 5 in front. You'll find different horizontal values because it's not going to be always stayed over 3 there as well. It's all going to change up a little bit. All right. Now going forward for the horizontals, I'm not going to explain like I did down here the whole quarter pi and kind of calculate out for you guys. I'm just going to say quarter of this is this. I'm just going to write it out. So if you need to like kind of pause the video, work through the quarter, half, and 3/4 period to find the first 3 horizontal points, be my guest. But I'm not going to take time to kind of write those out every single time. All right, so here we have -2 sine of 4 theta. So again, first thing we're doing is finding our amplitude. Absolute value of -2, which is positive 2. Our period is 2 pi divided by b, so 2 pi over 4 is pi over 2. So when we're setting this up, again, we're only really considering the positive side of this. We're going as high as 2 and as low as -2. We have 4 horizontal values to consider. The first one is the quarter period, so a quarter of pi over 2 is pi over 8. Next one is the half. Half of pi over 2 is pi over 4. Next is 3/4, which would be 3 pi over 8. And the last one is the full period, which is pi over 2. You should notice a consistent pattern. Pi over 8 is the first one, and the next one would be 2 pi over 8, reduces to pi over 4, then 3 pi over 8, then 4 pi over 8, which reduces to pi over 2. All right, so sine starts at 0. A is -2, so even though the amplitude is a positive 2, that's just simply distance. A is -2 tells us we start down below. We go down to -2 for the first point. And the pattern is we're at the valley. We then go to the mid, then to the peak, back to the mid. And it creates this curve right here. All right, so that's your basic sine functions. Whether the a is positive or negative tells you where you start after 0 going up or going down to then follow the pattern. Cosine you're going to find is going to be the exact same kind of process to find all the information. The only difference is how the graph is actually made. So the amplitude is still the absolute value of a. The period, again, is still 2 pi over b. Since we don't have any horizontal shifting going on, we're still only looking at the horizontal values. We're going as high as positive 4, because the amplitude is 4, and as low as -4. We still only want the 4 horizontal values there after 0. So the first one's the quarter period. Quarter of pi is just pi over 4. And then it's pi over 2 for the half, 3 pi over 4 for the 3/4, and then pi for the full period. Now, the way cosine works, sine always started at 0. Cosine always starts at a. So since a is -4, we're going to start there. And since we're at the valley, the only place to go is to the mid. Since we're going upwards, we then go to the peak. Once we're at the highest point, we then go down, so down to the mid, and then down to the valley. Again, try our best to make it look like a curve and less like a triangle. And there we go. You're not going to be losing points for how you're creating the shapes for my class. I'm just really looking forward to make sure I see this right here. I need to see the 4 horizontal values besides the 0 point. I need to see the y values. You don't necessarily need to list 1, 2, 3, 4 like that. You do want to, though, once you start talking about vertical shifting. You kind of need to list them out like that. But as long as I see the 4 horizontal values and I can see the points plotted in the correct locations, that's all I'm truly looking for. All right, so let's do another cosine one. So here we have the amplitude is a positive 3. Our period is 2 pi divided by 1/5, which is 2 pi times 5 over 1, which is 10 pi. So we set up our axis. We see that's a positive 3. Amplitude is 3, so we can go as high as 3 and as low as -3. our 4 horizontal values. So the first one is the quarter period. Quarter of 10 pi is 5 pi over 2. So everything's going to go up by 5 pi over 2, as you'll find, because the half period is 5 pi. 3/4 period is 15 pi over 2, and then full period is 10 pi. Like with the previous example, cosine is going to start at the value of a. Since a is positive 3, we're going to start at positive 3. And then since we're at the peak, we then go to the mid, then go to the valley, then go to the mid, then go to the peak. Connect them for a smooth curve. And there's our cosine graph. All right, so each of those represent the basic sine and basic cosine graphs without any sort of shifting. The moment there is some sort of shifting, though, horizontally and vertically, especially horizontally, things need a little more difference. It's a little more complicated. Honestly, the best way to graph, at least I have found personally, is that you graph the original trig function that would match this thing without the horizontal and vertical shifts. So what do we have without the plus or minus part there, inside and outside? Graph that. Only the amplitude, only the periods. And then you're going to shift those points around based off the horizontal and vertical shift. Because like if it's telling us to shift it pi over 2 to the left, we then just move each point pi over 2 spaces to the left. If it's saying like, -4, then we shift each point 4 down. So it's best is you do the original and then move them around from there for your transformations. At least that's what I find. All right, so let's take a look at a couple examples of both functions using this idea. So we have y equals 4 sine of 2 theta minus 3 pi over 2 plus 1. So we're going to focus on just simply y equals 4 sine of 2 theta. We're going to ignore the shifting for right now. So to do this, again, the amplitude is the absolute value of the a, which is just 4. Period is 2 pi divided by b, which is pi. So we set up our graph here. Now, for the shifting, we can see it's a minus sign, so we're going to shift right. So I don't need to worry about any of the negative side still. We can go as high as 4, as low as -4. We have our 4 horizontal points. Based on the period being pi, the quarter period is pi over 4, the half period is pi over 2, 3/4 is 3 pi over 4, full period is pi. So the original function, again, it's sine, so we're starting at 0. We're then going to go up, because it's a positive 4, to the peak, to the mid, to the valley, to the mid. We are not going to actually make our curve yet, though, because this is just simply the original thing based off without the shifting, the -3 pi over 2 part and the +1 parts. I'm going to label each of these points 0.1, 0.2, 0.3, 0.4, and 0.5 to help make it a little bit easier to see what's happening when we do the shifting parts. Because now the shifting takes into account the 3 pi over 2 and +1. So we need to factor the 2 away to identify the proper horizontal shift. Doing 3 pi over 2 divided by 2 gives us 3 pi over 4. So that tells us the horizontal shift means we're going to go 3 pi over 4 to the right. And our vertical shift is a +1, so it's 1 up. Now, it's not going to always be this case right here, but for our purposes, I'm going to match the horizontal shift with one of the horizontal values we already got from the period. You can recognize we're shifting at 3 pi over 4 right, and 3 pi over 4 is right here. 3 pi over 4 represents 3 spaces away from the origin, so this is really going to be 3 spaces to the right. Okay, so that way it matches everything up nicely. You don't have to go too crazy finding new points or going backwards. So we only need 3 new spaces. Now, you'll notice the way we're going to fill in those 3 spaces is the first point, that quarter period, that's how much everything increases by. It starts at pi over 4, so everything's going up by pi over 4s. So pi over 4, 2 pi over 4 is how we got pi over 2. 3 pi over 4, 4 pi over 4, that's how we got pi. The next one's 5 pi over 4. Then it'd be 6 pi over 4, which becomes 3 pi over 2. And then it'd be 7 pi over 4. So we plot our final graph. Each of the original points in green, points 1, 2, 3, 4, and 5, are going to shift 3 spaces right and 1 space up. So point 1 is going to go here. Point 2, well, we're going to go up 1, so we need an additional space there, is going to go here. Point 3, again, 3 spaces to the right, up 1 is going to go there. Point 4, 3 spaces right, 1 up is going to go here. And then point 5, 3 spaces right, 1 up is going to go there. So we connect that. It's still the same recognizable sine curve. But it's now shifted away from the starting point, the origin at 0. So that's what we're going to be doing for each of our additional sine and cosine transformation graphs. We're just simply applying the original without any sort of transformations for the horizontal and vertical shifting. We're then going to figure out what was the horizontal and vertical shift. You'll find the horizontal shift will always match in some way one of the horizontal values from the quarter, half, or 3/4 periods. So it's either going to be shifting 1, 2, or 3 spaces. It obviously does not have to always do that. If it's not, it does get a little bit more complicated. The idea is you're just simply adding on from the original point. So if it was only going, let's say, like, pi over 6, you'd add pi over 6 to each of the original 5 horizontal values to get your new horizontal values. But just to make our lives easier for these curves, we're just going to do it based on the exact period values. Okay, so let's take a look at another sine one, then we'll do some two cosine ones. So again, we're only graphing this thing based off the original -2 sine of theta over 3. So the amplitude, absolute of -2 is +2. Your period, 2 pi over 1/3, 2 pi times 3 over 1, which is 6 pi. It's a plus pi there, so we are going to have negative portions to this. So I'm going to leave myself enough room to have a negative side. I do my axis. We have our 4 horizontal points still. We're going to have 1, 2. It's going up 3 though, so we're going to go up as high as 5 for our points. And again, the horizontal values are the quarter period, which would be 3 pi over 2. The half period, which is 3 pi. The 3/4 period, which is 9 pi over 2. And the full period, which is 6 pi. So our original points, I'll do in blue. Green doesn't really show up too well. Starts at the origin, 0, 0 for the first point. It's a -2, so we go down to -2 for the second one. And again, following that pattern, we're at the valley. We then go to the mid. We then go to the peak. Then go back to the mid. So those are our 5 points we're working with. Now for the horizontal shifting and everything else, we recognize we need to factor out the 1/3 away from the theta and the pi. Dividing by 1/3 is multiplied by 3, so it becomes plus 3 pi here. So our horizontal shift is 3 pi to the left, which you can recognize 3 pi is the second point, so this will be 2 spaces. The vertical shift is plus 3, so it's 3 up. So each point is going to go 2 spaces to the left, so I need 2 more horizontal points here. The nice thing is for the negative side is just simply a reflection of the positive side, just with negative. So this would be -3 pi over 2 and -3 pi. If I need a third one, it will then be -9 pi over 2 next, -6 pi after that, and so on, just kind of reflecting on the negative side. So our final graph, which I'm going to plot in red, we're going 2 spaces left and 3 spaces up. So our first point is going to go there. Our second point is going to go here. Our third point is going to go here. Fourth point there. And then fifth point here. And that's going to create our sine curve. A little more symmetric looking. That's simply because it's symmetric about the y. Well, not really symmetric fully, but it's kind of centered around the y-axis. All right, so that's our process using our shifting. So we're going to find the cosines going to be the same kind of way, only obviously since the cosine graphs start a little bit differently and make a slightly different shape, it's going to look a little different, but it's still going to be the same, general concept. So we got this one right here. So we have our... Well, first off, it's kind of like switched around the order-wise. So you might want to move it around and rewrite this as -4 cosine of theta over 4 plus pi over 2 minus 1. Recognizing the number that's multiplying with cosine or multiplying with sine should come first. The number that's adding or subtracting on after that, or even before that, should then go on the very end. So our amplitude is based on the opposite of -4, which is +4. Our period is 2 pi divided by 1/4. 2 pi times 4/1, which is 8 pi. It's also a plus sign, so we are going to go left, so I'm going to leave myself some room to shift it left. So we're going as high as +4. We're going to go as low as -4, but it is going down because I see the -1 there, so I'm going to have a -5 there. So we have our 4 horizontal points. Recognizing the first point is the quarter period, so that'd be 2 pi. And the half period, 4 pi. 3/4, 6 pi. Full period, 8 pi. So for our graph, cosine starts at A. So since A is -4, it's going to start at -4 for that first point. And then goes from the valley to the mid, to then the peak, back to the mid, back to the valley. So now we got to do our shifting. So again, the shifting is now based on factoring the 1/4 away from theta over 4 and pi over 2. Remember, if we're factoring, we are dividing. So it's pi over 2 divided by 1/4, which is pi over 2 times 4/1, which is 2 pi. So for the horizontal shift, we are going 2 pi to the left. 2 pi is the first point, so it's only one space. And then the vertical shift is the -1 at the end, so it's 1 down. So we need one horizontal space to the left, so a -2 pi right there. So again, each point is going to go 1 left and 1 down. So point 1 is going to go here. Point 2 is going to go there. Point 3, 4, and then point 5. Again, doing our best to kind of create and make a U shape here. Also, because you are making your own grid, it may not be like, perfectly evenly spaced or everything. Just do your best to make everything as evenly spaced as possible. If you want to bring a ruler so you can kind of draw perfectly straight lines, all that kind of stuff, be my guest. Don't go crazy, but at the same time, don't make it too obvious that it's very sloppy. All right, so first thing, again, if it's not in the correct order, just make sure you rearrange the thing so it is in the proper order. And then from there, just applying your cosine points and shifting them around. So if you have not yet done so, you really should try this last question, example 10, on your own. And then we'll talk about it, and you'll make sure your answer matches mine. So pause it, work it through, compare to mine. Well, the first thing we're doing is we're rewriting it into the proper order. Recognizing our amplitude is the absolute value of 3, which is +3. Our period is 2 pi over 4, which is pi over 2. It's a minus sign, so we're only going to the right, so I don't need to worry about any negative horizontal values. So we know that it's an amplitude of 3, so we can go up as high as +3, and as low as -3, but it's a -2, so we can go down 2, so we're going to really go as low as -5. The horizontal points are based on the quarter period. A quarter of pi over 2 is pi over 8. And then a half of it is pi over 4. And then 3/4 is 3 pi over 8. And then the full period is pi over 2. So for the original cosine without the horizontal and vertical shifting, it starts at A, so it starts at 3. Since that's the peak, it then goes to the mid. And then it goes down to the valley. Back up to the mid. Back up to the peak. Now for our shifting, well, we have to factor. So we factor the 4 away from theta and pi. So doing pi divided by 4 is pi times 1/4, multiplied by the reciprocal, which is pi over 4. So the horizontal shift is pi over 4. It's going to go right because of the minus sign. Pi over 4 is the second point, so it's really 2 spaces. And then it's a -2, so the vertical shift is going to be 2 down. So the final points, we're going to go, each of these points is going to go 2 spaces to the right, and then 2 spaces down. So point 1 is going to go here. Point 2 is going to go there. Point 3 down to here, and then we do need 2 more horizontal spaces on the right side. So we need to recognize what those are going to be. The first point is pi over 8, so everything goes up by pi over 8. So it's 1 pi, 2 pi, 3 pi, 4 pi over 8, then 5 pi over 8. Then 6 pi over 8 reduces to 3 pi over 4. So then those next 2 points, point 4 is going to go 2 spaces to the right and 2 spaces down. So it's going to go right there. And then point 5, the last one, goes 2 spaces to the right, 2 spaces down. So it's going to go right there. We connect them to make our curve. That's our final graph right there. So obviously, again, I'm also color coordinating all this stuff simply because I have the ability to use different colors there. I don't really need to see that from you guys. All I need to see to make sure you have the full answer there is what I have there in red, that final result. That's what I'm looking for. You're obviously going to have to show me the amplitude, period, horizontal shift, vertical shift, the factoring for the horizontal shift, all that kind of stuff. In order to get to that, you're going to probably want to show me the original points as well to help show where you're shifting everything, but I'm looking for that final curve. And I need to know these horizontal values that match up the final curve based off this. Yes, technically it oscillates infinitely forever, so theoretically you could show me a different curve that is actually correct, but I'm looking for the curve that's based on the starting at 0 and then shifting based off the horizontal and vertical shifts. So I'm not looking for any other parts of this curve. I'm looking for this exact answer right here. All right, so make sure you're careful when you're setting that up. All right, so that's your sine and cosine functions. You're going to find the next video, 6.5. We're going to talk about cosecant and secant. They're actually use a lot of the stuff. In fact, everything we just did here is going to be used to create those curves. They're just going to look a little bit different because they're different functions. As always, thank you for watching, and I'll see you next time.